Hello, everyone. You are welcome to today's meeting. In today's meeting class, we have uh, a short, in fact, it will not be short. Okay, we are going to look at another aspect of what differentiation in terms of what the rules. In fact, we've dealt with the basic rules. Okay, we are going to continue from where we left off. In our previous meeting, remember, we were looking at how to differentiate composite what functions or differentiation using the composite function rule or the chain rule. And you were given an assignment which we'll look at the solution to that assignment pretty soon. But before that, let's go and look at our last aspect of what the rules or techniques in differentiating functions. Okay, and just as you have on your screens, we have differentiation of implicit function. Before we delve into that, please, if you are yet to subscribe to my YouTube channel, do so. Okay, subscribe, like, and share for content like this. Okay, so let's look at all the functions that we've differentiated so far. If your function may be, if it's f of x, j of x, what have you, we can represent that by y. But I've told you, if it is f of x, j of x, h of x, we can still differentiate without doing that representation. But for the purposes of what I'm going to say, my explanation, that I'm going to give, assuming all our functions are labeled y, you can say that you have y is equal to something. So in that relation or function given, you will know that your y is explicit, meaning y is made to stand alone. Y is made the subject. And therefore you are able to differentiate straight away. But it will not be all situation that y will be what? Explicit, meaning y will stand alone. Y will be made a subject, or y is already made a subject and you'll be asked to what? Differentiate. So if y is not made a subject in that relation, or in that equation, if I should so put it, you should know that your differentiation must be done implicitly. So you'll be dealing with what? Implicit function. And we are going to look at how to deal with what? Implicit function in terms of differentiation. But before we can deal with implicit function, we should be able to recognize what such functions. So, let me take you through this, which will help us do that. An implicit function is a relationship where the dependent variable is not explicitly isolated on one side of the equation, but is instead defined by an equation involving multiple variables. So it means your dependent variable will not stand alone on itself, will not be the subject, will not be made a subject, will not stand alone. In that case, it means that your dependent variable, will be mixed with what? Other variables in what? In the equation. And when you have such a situation, then you are dealing with what? An implicit what? Function. So example, x squared plus y squared is equal to 9. You can see that in this relation that we have here, the relation that we have here, y is not made the subject. So it means this relation is what? An implicit what? Relation or function. Same, when it comes to the second one and the third one, y is not made what? The subject in each of them. Y is not standing alone. With its power being 1 and its coefficient being what? 1. Is my point well made?
Yes, please.
So once we know how to identify such functions, let's look at the technique that we need to adopt in differentiating such function. But before you appreciate that, you need to take note of this. So let me take you back to what we were doing. So let's see. So if I have d, I'm coming, d dx of x, what would that give me?
Dx dy.
No, dx of x.
Dx dx.
Oh, so dx dx will give you
1.
1. So you know you are differentiating this. The power is 1, so the coefficient becomes the answer. So you should know that it's 1 straight away because it's coming from dx ds. Is that clear?
Yes, sir.
Yes,
Okay,
please.
so in the same way, if so in general, so let me start from, if I have d dx, okay, of s squared, what would that give me?
2x.
2x. Very
2x.
good, very good. So in general, if I have d dx, okay, of what? X to the power n, what would that give us?
Nx.
Nx,
Raise the power n minus 1.
n minus 1. Very good. Okay, so you can see that in this situation, okay, the variable here, which is x, okay, is the same as the variable that you are differentiating with respect to. So you can see x here, you can see x here. So in that case, you know, okay, at the normal circumstance, remember I told you that it's supposed to be times d dx of what you have here to the bracket. When it's supposed to be times d dx, okay, of x, which we know will be 1. So we usually don't consider it. You remember I said that?
Yes,
When I was taking you to the composite function rule. Okay, so once that is clear, then let's see. Okay, if you have d dx, okay, of y, what did we say this will give us?
1.
D dx of y will give us our usual. Oh, our usual d dx of y.
dy dx.
dx, usual dy dx. So you know, anytime you are differentiating, you know you are supposed to differentiating y with respect to x, you get dy dx. Okay, so that is what we have, dy, okay, dx. Okay, and please take note. This is what is happening. Okay, anyway, before I say exactly what I have there, I think I can skip you amateur if you don't get it from where the angle that I'm going to come from, then I will go back to what I wanted to say initially. So you can see that here, okay, if this was x, okay, the y was x, your result would have been 1. Is that not it?
Yes, please.
But because the y is not x, the variable that you have here is not the same as the variable that is here. Okay, it means, okay, the dy dx, okay, must be attached. So this is it. Anytime you know, so now let me come back to what I have here. You can see that I'm looking at d dx of y to the power n. Is that not it?
Yes, please.
If it was x to the power n, then you know we'll end up getting the result that we have here. Is that clear?
Yes, please.
Okay, so now let's see what is going to happen. We said anytime you are differentiating, okay, any, okay, function to a certain power, we make use of the composite function rule. Okay, you get the point. Then the composite function rule, what do? We said we have to bring the power down. Are you with me?
Yes, please.
Keep your variable, reduce the power by 1, but that's not all. Times what? Let me write it so that you can follow. So we are going, if you are finding d dx, okay, of y to the power n, remember, if we are differentiating any function to a certain power, okay, what do? We said this will be equal to, bring the power down, like we said, keep your variable, okay, that you are raising, or the function that you are raising to the power, reduce the exponent by 1. But that is not all, times d dx of your function, okay, or the variable that you are raising to the power. And what is the variable carrying the power?
Y.
Y. From where we are coming from. Is that clear?
Yes, please.
But we know that, okay, here, if you continue based on, okay, what we have acquired, this will give us y to the power n times y to the power n minus 1. But d dx of y we know will give us
dy dx.
dy what? dx. So that explains, okay, what we have here. So it means anytime you are differentiating, please take note, anytime your operator d dx is affecting y to a certain power, okay, there will always be this factor dy dx multiplying, okay, your power brought down, your function, okay, its power reduced by 1. So this factor will not be, okay, 1, as we had in the situation where this was x. So if the variable here and the variable here are not the same, there will always be d dx of that variable attached, okay, or brought at the end of your differential. Should I come again, or my point is well made?
Sir, please come again.
Please come
Okay,
again.
all right. So maybe I will use this example, okay, where the illustrative example here to drive home my point. So I have d dx of y squared. If we are differentiating any function and you see that the function, okay, is raised to a certain power, we said we are supposed to use the composite function rule, okay, or the chain rule. So what do? We bring the power down, okay, that will give us 2. Keep your function, in this case, that is y, or your variable y. Then what do? Reduce the exponent by 1. So it will be 2 minus 1, which will give us 1. I didn't write it because it's simply understood to be there. Is that clear?
Yes, please.
Then times what? D dx of what? Y. If what you have here was x, it would have been times d dx of x, which will give us 1. So we can choose not to attach that factor, d dx of the function that you are raising to the power. But here, d dx of the function here will not give us 1, so we have to attach it. So it means what we have here at the normal circumstance in terms of what explanation will give us. Let me go and clear what we have there. I'm coming. Okay. So let me see. Let me clear then have room. This is the foundation. And you know that usually the foundation I talk more. Okay. So I'm going to, as for the X situation, you understand. Now we are looking at the Y situation. Y situation, you know one of them, which is the d dx of what? Of Y. You know that will give us dy dx. So that's if the power of the y is 1. But if the power of the y is not 1, how do you get its result? So we are saying that if you have d dx, okay, of y, okay, squared, this will be equal to bring the power down, keep your y, reduce the power by 1. So it will be, okay, I'm writing just for explanation purposes. But that's not all, times d dx, okay, of y. Okay, so it means this will give us what? 2y to the power 1. You don't write it. Then d dx of y will give us dy dx. All correct.
Yes, please.
Is my point well made now?
Yes, please.
Yes,
Okay,
sir.
so likewise, if indeed it's yes, let's see. If maybe you have, okay, d dx, okay, of y cube, what would that be equal to?
3y.
The entire class. Let's at least let's say something. If you are wrong, you'll be
3y.
corrected.
3y
3y
squared.
3y
squared
dy dx.
dy
D
dx.
dy dx.
Dy dx. So once there is a y term, okay, and or a y factor, and you are differentiating with respect to x, there will always be a dy dx factor in your differential. Is my point well made?
Yes, please. Yes,
Okay,
please.
very good. So if indeed, okay, Prof. Ernest,
Sir, can we have an instance where instead of it being 3y, it will be 3x?
which one? Which one will be 3x?
Like the way you've done 3y squared dy
No, so if
dx.
it will be x, then it means the variable that you are differentiating with respect to, I mean, this will be x, so that you see x here. In that case, I hope you get my point.
A bit, sir.
Okay, so you are differentiating this. If let's say you had d dx of what? Because I have y. Okay, because I have y to a certain power, it means okay, if I bring the power down, I have to keep my y, and its new power will be the reduced version of the power by 1. Okay, so it means whatever I'm going to, after bringing out the power, okay, I will have y involved. But if it was d dx, okay, of x to the power n, if I bring the power down, I have to keep my x. So that is the situation where this will be x. If this is y, this cannot change towards x. If this is x, this cannot change to y. Because the rule is bring the power down, keep your variable that you are raising to the power. So if your variable here is y, okay, and you are keeping it, it will still be y. It cannot change to x. If it is changing to x, then it means this was x. I don't know, Prof. Ernest, if you get my point.
Yeah, I do.
You do. So once you have, okay, a variable to a certain power, if you bring the power down, you keep your variable, you maintain your variable. So it means you have to see your variable, okay, there before you reduce the exponent. You don't replace your variable with any other variable. All correct now?
Yes, sir.
Okay, so now I'm going to build your foundation for the task ahead. Usually when you are asked to differentiate a function, okay, implicitly, or if you have an implicit function and you are asked to differentiate, okay, you will get a relation. You get something is equal to something. Okay, but every relation will have terms. So you will be differentiating terms. So if you don't know how to differentiate the terms, okay, you wouldn't be able to differentiate the entire relation. So I'm going to guide you to know how to differentiate, okay, terms. And then later we go and put, okay, everything together. Then, okay, we will get a relation and move on to differentiate, okay, usual implicit what functions. So now let's go. I think we have done the A. So find the following. So question 1, solution to major question 1. Okay, A, what are we supposed to? So we are asked to find d dx, okay, of what? Of y cube, and that's what we just did. Okay, so this will be equal to
3y squared
3y
ddx.
squared dy
dy
dx. Okay, dy dx. Okay, so I can write therefore this is equal to that. Okay, then let's come to the B. Okay, we are doing it together. So B, okay, what are we giving? D dx of what? Of 2y to the power 4. Okay, so you know the rule. This will be equal to, so let me even write therefore here. Okay, then come down as you've been advised. So my first step, this is an expression. So I start with the equal to. Okay, what I've been given, it doesn't involve any inequality sign, any equal to sign. So I start with equal to. So now you know what is the rule. Bring the power down. Is that not it?
Yes, please.
So if you bring the power down, it will come and multiply the 2. So that will give us 8.
8y.
Okay, 8, you keep your variable y, reduce the exponent by 1. So that will give us
3.
3. But that's not all, because the variable here is not the same as the variable that you are differentiating with respect to, okay, that factor d, okay, your variable here, dx, will come in. So it will give us dy, what, dx. Okay, factor there. Afa,
Yes, please.
my professors, are you following?
Yes, please.
Yes,
Okay,
please.
all right. We thank God. So I've put therefore here. So it means my conclusion is embedded in my step. So now let's come to C. Okay, I want the entire class. So help me do the C. Okay, together. C, what are we giving? Okay, so we've been given d dx. Okay, of what? 5y to the power what? 6. Okay, so in this case, okay, we are going to get equal to, help me, the entire class.
31.
Okay, so 30, you multiply this and this, which will give us 30. Y,
To the power 7.
to the power?
dy dx.
To the
7.
power? A.
8. 5. 5. 5.
5. You are subtracting, no, you are not adding. Okay, 5. Okay, then because the variable is y and you are differentiating with respect, there will be that factor dy dx. Alpha.
Yes,
Yes,
please.
please.
Okay, so that will give us then, don't forget, we've not drawn our conclusion. So instead of writing therefore this is equal to that, you can come and put it here. Okay, just to establish the same, okay, point. All right, any questions here before I will move on to, okay, the last 3 questions? Okay, so we are all fine at this point.
Yes, please.
Okay, great. We thank God. All right. So assuming, okay, in this question, assuming all your y's, okay, were x. So maybe assuming, so in this case, if I had d dx, okay, of x cubed, what would that give us?
3.
3
3x squared.
s squared. You end there because that factor that you are supposed to multiply, which will be d ds of s, will give you 1. So because the variable here is the same as the variable here, that factor will always be 1. You get the point?
Yes, please.
If it is not the same, then it will give you d ds of that variable, which will give you that variable dx. Is that clear?
Yes, please.
Yes, please.
Okay, very good. Okay, so now let's go and look at the d. Okay, so d. Okay, what do we have? D dx. We've been given d dx, okay, of what? Minus, so I'm putting it in bracket because of the negative. So minus 4, okay, y to the power 5. Okay, so let's do this one also together. So this will be equal to
minus 20
minus
minus
20y to the
20
power
raised to
4
the power
y
4
to the power 4
dy
dy
dx.
dx.
dy dx. Very good. The future is very, very bright for me. Okay, dx. Okay, so this is what we have. Okay, so on that note, okay, I would skip the e, then we are going to do the f, where the coefficient, okay, is a fraction. But even based on what I've done so far, I can even skip the e and f. Now let's do the f, okay, together. So f, if you're able to do the f, you should be able to do the e. F, what are we giving? Okay, d dx of what? Don't forget your therefore, you've not drawn your conclusion. So d dx of what? Okay, minus 2 on 3. Let me write my minus 2 on 3 what? Y to the power 9. All correct.
Yes.
Yes,
Yes,
sir.
please.
Okay, so there's an expression you start introducing your steps with equal to. So what do? You bring the power 9 down. Let me write the 9. Well, 9 down. So that will come and multiply to be 9
Minus
times what?
6.
Minus 2. So then 3 will go here, 3. Is that not it?
Yes,
Yes,
sir.
please.
Okay, so I'm doing it mentally, but if you are not, you can do it as a rough work. You know, it will be minus 2 on 3 times, you bring the, sorry, on 3 times, you bring the 9 down, then you keep your y, reduce this, but if you, this will go here 3, so it will be minus 2 times 3, which will give us minus,
Minus 6
minus 6,
y
then your y to what power?
to cubed 3.
No, the y, the exponent is 9, oh.
Tell to be 8.
It will be 8. You get it
8.
right?
Yes,
Yes,
please.
8,
please.
you reduce the exponent by y. Is that all?
dy dx.
dy dx. Okay, so don't forget. Safa.
Yeah.
Yes,
Okay,
please.
very good. You are doing well. Keep it up. Okay, so that will be it for the first set of what work example. Now let's go and look at the next set. Okay, so let's see. Okay, another situation. Okay, let's go back to what we were dealing with. Okay, you can see that here your differential operator ddx is affecting a function, but that function that you have there involves only one variable, y throughout. Can you see that?
Yes, sir.
Okay, now let's go and look at the other. Okay, so with this, okay, you didn't hear me. I said you can see that ddx of the function that you have, you are taking the operator is affecting, contains only one variable. That is x. Sorry, y. Can you see that?
Yes, please.
Okay, now let's come back to this. You can see that here, what you are differentiating, you are taking ddx of this. This contains how many variables?
2 variables.
2 variables, x and y. 2 variables, 2 variables, 2 variables, 2 variables, 2 variables. Okay, it's the exponent, okay, and coefficient that vary. But the variables involved, okay, in each question the same, x and y, 2 variables. Is that clear?
Yes, please.
So now let's see how, okay, we deal with this situation as well. Okay, if you understand this, then the future will be very bright. If you go and look at implicit function in itself. Okay, so now, again, find the following. So 2, solution to question number 2, major question number, I will come to A. Okay, what are we giving? D dx, okay, of what? xy. Is that clear?
Yes, please.
Okay, so now this is the only additional information that I'm going to give. If you see xy, what does it tell you in terms of algebraic expression? What is the meaning of xy?
X times y.
X times y. X and times is the same as product. Is that not it?
Yes, please.
So it means you are differentiating products of 2 functions. So what should come to mind? What rule?
The product rule.
Product rule. You get the point.
Yes, please.
Okay, so once we have product rule in mind, this is what we are going to do. So this is what you are supposed to do. This will be equal to, product rule, we hold, so this is the product of x and y. So it means we are going to hold our first factor, differentiate the second factor, then do the swap, plus the swap. You get it?
Yes, please.
So it means if you differentiate xy, because you have two factors, we are going to get two terms. Remember, the first term will be your first factor held, second factor differentiated, then the second term will be plus. Okay, then you go and take the swap. So if I hold my first factor x, I'm going to write this for explanation purposes. Okay, so I will hold x, then find d dx, okay, of y. Do you agree?
Yes, please.
Yes,
Then
please.
plus, we come and hold y, then find d dx of what?
X.
Of x. Okay, so you know this will be equal to, if I hold x, x is held. Okay, d dx of y will give us
Dy dx.
dy dx. Very good. Okay, then plus, if I hold y and differentiate x, if I find d dx of x, what do I get?
1.
1. My professors, I hope you are following.
Yes, please.
Okay, is everyone following?
Yes, please.
Okay, so now this will be equal to x,
So,
okay, dy
so
dx. Let me land, I will come to you. Okay, then plus what? Y. So it means the result that we have here will give us this. I mean, d dx of xy will give us what we have there, the result there. So now, okay, let me go and clear that. Okay, all right. Prophetess, were you the one?
yeah, I wanted you to go over from the x d dx y plus y d dx x.
Okay, all right, no problem. Okay, so here you said you all agree that xy means the product of x and y. Is that not it?
Yes, please.
So I know that my operator is affecting product of what? Function. So which rule comes to mind? And you said obviously product rule. And by the product rule, we said hold the first function, your operator will affect the second function, meaning find d dx of your second factor, I should say. Okay, or function, I can, because remember when we're doing the product rule, we use two functions, f of x and g of s times what? G of s. Do you remember?
Yes, sir.
Okay, so x is my first function, then y is my second function in this case. So I hold my first function, differentiate my second function, and anytime I'm differentiating, I should know my differential operator. So the operator is d ds, so d ds of y, then plus I hold my y, then come and find the differential of or differentiate my first function. Hold the second function, differentiate the first. So it will be second function y held, d ds of what? X. So this is coming from the application of the product rule. So we didn't do anything, okay, special. We just fell on a rule that we know. So x, okay, kept d dx of y and our usual dy dx plus y, okay, kept d dx of x will give us, if the variables here are the same. So that will give us, okay, remember the coefficient, or if you still want to use the power rule, you deal with that. And that will give us 1. Then now we come and remove the brackets here, which gives us the result that is here. Is that clear?
Yes, sir.
Okay, very good. So that will be it for A. So you can see that's the question moves, okay, from one question to the next. Okay, you see a little more bones. Okay, but once the first one is good, okay, I know that the second one, okay, will even be better. So let's go and look at what B. B, what do we have? Okay, and we've done our conclusion for the A. B, what do we have? I'm moving away so that in case I need to draw my conclusion, there will be space for me to put the therefore. So I will always move a little away, okay, by experience. So I will get d dx, okay, of what? X, okay, y squared. Okay, so again, your operator, if you see xy squared, we know this is the product of x and y squared. Do you agree?
Yes, please.
Okay, so again, I mentioned product. So it means I'm going to deal with what the product rule. Okay, so with that, I'm going to write this. So this will be equal to, by the product rule, we hold the first function, which is x. Are you with me?
Yes, please.
Then we come and differentiate the second function. But if we are differentiating the second function, we need to know our differential operator. What is the differential operator?
Dx.
No,
D dx.
d dx. My professors, are you with me?
Yes, please.
Okay, so I'm going to
Yes.
take d dx of y squared, which is my second function. D dx of what? Of y squared. Okay, then plus, I come and hold y squared, my second function, then differentiate my first function. So that will be d ds of my first function. Is that clear?
Yes, please.
Okay. All right. So if I move on, this will be equal to, all right. So remember x held. Okay, now we are experts where we are coming from. d ds of y squared will give us
2y
2y.
plus y squared.
No. Where we are coming from. Even I was giving it there. 2y
Why yes?
dy dx. So it means there is a missing gap. You see the way I teach. Let's go back. I've taught you how to deal with that. Even in the example, this is it. So we know that if we find d ds of y squared, that will give us this result. Remember, bring the power down, keep your variable, reduce the exponent by 1. But because the variable here and the variable here are not the same, it will be d, your variable here, dx. Okay, so that's what we are going to do. Okay, in this case, so it will be, you bring the power down, keep your y, okay, then what do you do? Times what? D ds of y, which you know will give you, always give you dy ds. So reduce the power by 1. So it will be 2 minus 1. I won't write it there. Simply understood to be there, 1. Then times what? D ds of y. So that will give us dy ds. Is my point well made, my professors?
Yes, please.
Yes, please.
Okay, but that is not all. Plus, so I close it. Okay, then plus. This is the result I have in bracket here, the differential of the y squared. Then plus, I keep the y squared. Okay, then go and differentiate what? The x. So d ds of x will give us 1. Okay, so because the variable here is the same as the variable here, this factor here will be 1. So usually, you know. Okay, so in effect, this is going to give us, if I multiply, I'll get 2xy, okay, dy dx. Okay, then plus y squared. Do you agree?
Yes, please.
My professors, are we fine?
Yes, please.
If you are able to get the product, if you're able to get this, okay, all that we are doing here, the future will be very bright. So please, if you are not getting it, prompt me. Otherwise, going forward, okay, you will struggle because we are going to combine all that we have done so far in dealing with the subsequent, okay, questions. All right, so now let's go and look at what? The C. Okay, C, what do we have? We are finding, did you draw a conclusion? Not yet. So I'm talking about the B, so you can't even put F4 here. So you can see that I'm always on the guard. Okay, before I move on to the next one, I will ask myself, did I draw conclusion for the previous one? If the answer is no, I go and do that. If it's yes, okay, then I proceed. Okay, so now the next one, we are finding C. We are finding d dx, okay, of what? X squared, y squared. Okay, x squared, y squared, what is its basic meaning?
Xy all squared.
No, the basic meaning.
X squared times y squared.
X squared times y squared. Okay, I didn't say, okay, how, else can we write it? I'm looking at the meaning. Okay, so in this case, what do we have? Okay, so once we said x squared times what? Y squared, it means the product of x squared and what? Y squared. So product rule. So by the product rule, okay, we said we hold the first function, which is x squared. So product of x squared and y squared. So hold x squared, then come and find d dx of y squared. All correct, my professors.
Yes, please.
Then plus, okay, come and hold y squared. Then find d dx of which function?
X squared.
S squared.
X
No, s squared. Okay, very good. So in this case, this is going to give us hold the s squared, which has been held. Okay, then we are finding d dx of y squared, which we know will give us
2y
2y dy dx.
dy dx. Very good. Okay, then you close it. That will be it for the differential of that. Then plus you hold the y squared. Okay, so if you differentiate x squared, what do you get with respect to x?
2x into bracket 1.
2x into bracket 1 will not be necessary, so it will just be 2x. You get it?
Yes.
Yes, please.
Okay, so it means if if the variable here is the same as this, just bring the power down, keep your variable and reduce the exponent by 1. Don't multiply it by anything. But if it is not the same as this, bring the power down, keep it, okay, keep your variable, reduce the exponent by 1, but that's not all, times ddx of what your y. So now we know that after bringing the power down, keeping the variable, when the variables here are not the same, and reducing the exponent by 1, there will always be a dy dx factor that must be brought at the end. You get it?
Yes,
Sir, please,
please.
can you repeat yourself again?
Okay, I said based on what we've done so far, anytime you are differentiating, okay, finding d dx of, okay, per the rule, y to a certain power n. Okay, the rule is that, okay, we bring the power down, keep your y, reduce the exponent by 1, but that's not all. There will always be a factor dy dx at the end because this variable here is different from this. So it will be d dx of what your variable y, which will give us dy dx. So if this was z, it will have been nz to the power n minus 1, then dz dx. Is that clear?
Yes,
Yes,
sir.
please.
Okay, good. Okay, so now we are not done. We need to go and remove the brackets. So if you remove the bracket here, we are going to get s squared times 2y, which will give us 2s squared y. Am
2
I
x.
right? S squared
Yes,
y.
please.
That times was dy dx.
Mm.
Okay. Then plus, if you remove the bracket here, you are going to get 2x what? Y squared. Okay, profitable.
Sir, please, you said the power rule is taken from the chain rule.
Yes.
Sir, please, so is it appropriate to use the chain rule instead of the power rule?
So that's what we use. We use the chain rule.
I was having difficulty like differentiating between the two.
Okay, the power rule. If you know, I gave you the power rule. Usually, we mention the power rule when the variable that you are differentiating with respect to is the same as. So if you have d dx, okay, then x to the power n. That's where you use the power rule. The variables here are the same. So bring the power down, keep your x, reduce the exponent by 1. That's all. That's the power rule. Okay, with the composite function, remember, with the composite function a rule, okay, we said, or the chain rule, we said in that situation, okay, your function here, okay, what you have here, because I told you that one will be times d dx of what? Your function. Your function what? X. Okay, however, this factor will be 1. Let me use the dot to represent. So once you realize that that factor will be 1, then it takes you back to the power rule. But if it will not be 1, then it becomes the composite function rule. So it means what we did here, we apply the power rule because, okay, this variable and this variable the same. When we multiply this one by, remember I told you that even the power rule, okay, contains, what do you call the chain rule contains the power rule. The power rule is a subset of the chain rule. So that's a special situation for
Yes.
the chain rule or the composite function, where the variable here is the same as that. And when you differentiate, okay, that factor will be 1. I'm talking about times d dx of x. That will give you 1. But if it won't give you 1, then it means you use the chain rule or the composite function rule. You get it?
Yes, sir.
All right. Okay, Prof. Frank.
Please, I'm a bit confused about how, like, you expanded the bracket of the x square and the 2y of the y
Oh,
dx.
you are multiplying. This is the same as s squared times 2 times y times dy dx. So if you are multiplying, you know, as for the dy dx, that will be kept, that will be brought at the end. In math, if you are multiplying, you have a constant variables. You bring the constant first, and the variables, you write them in alphabetical order. So it will be 2 times s squared times y. So that will give us 2s squared. Your constant, you bring it out. Okay, so if I give you, okay, 2 times, let me use the 2 times x, okay, times what? Y. Or let me say times a. How would you write your answer?
Sorry, yeah.
2 times x times a will give you Prof. Frank, what would that give you?
Is 2ax.
2 what?
Ax.
2ax. Okay, you brought the constant, okay, first. Okay, numerical constant first. Okay, then what you, okay, introduce your a, then the x. Someone can also write xa. Okay, the two are the same, only that it is advisable you move alphabetically. That's why you said ax. Is that not it?
Yes, please.
All right, so it's the same concept that we use here. Is that fine with you now?
Yes, sir.
All right. Okay, I saw a hand up. Carol,
Is
were
that
you?
one, please? Yeah, I wanted to answer the question.
Okay. All right. Okay. Okay. So anytime someone asks a question and I'm addressing the question indirectly, okay, is the person, okay, if I ask a question, is the person that I want, okay, to answer, though it's for the entire class, but specifically for that particular, okay, student. All right, take note. All right, so now let's go. I think we've done the C. Okay, 3 more to go. Okay, so let's see. D. Did we conclude? We didn't conclude. So you can see that when I was moving to D, I asked myself. That's why I'm able to go back and do my conclusion. Okay, so now D. Okay, what are we giving? D, dx, okay, of x cube, okay, y cube. Okay, so now we know this will be equal to, what is the meaning of x cube, y cube?
S cube times Y cube.
Okay, which is the same as the product of x cube and y cube. Is that not it?
Yes, please.
Okay, so now we know product rule. So hold the x cube, then you differentiate what the, okay, y cube. So this time I'm going to handle it maturely, which you can also do as you mature. So I know I'm going to differentiate the y cube. So I'm finding d ds of y cube. Let me write it. Okay, as you go forward, then okay, I can do that before some of you will be confused. So it will be d ds of y cube. Okay, plus I come and hold what, my y cube, then find d ds of what?
X cube.
S cube. My professors, I hope you are following.
Yes,
Yes.
please.
Okay, so this will be equal to, okay, s cube held. D dx of y cube will give us, let's go,
3y squared
3y
dy
squared
Yes.
dy
dy
dx. Okay, so dy dx factor will come in because the variable here is not the same as this. Okay, then plus y
y
cube.
cube
Okay, if you differentiate this with
x
respect to
squared.
x, okay, you get, the variable here is the same as this. So that will give you, bring the power down, you use just the power rule, keep the variable, reduce the exponent by 1, and that will be it. Okay, there wouldn't be any factor that will come to the end. That factor will be 1, so you can ignore. Okay, so in this case, this will be equal to, okay, we are going to multiply. So Prof. Frank, help me do this expansion to convince me that you understood the initial explanation.
It's 3x cubed y cubed divided
Why?
3x cubed y squared
Very good. All right.
dy dx.
Dy dx. Okay, so I think you are cool. All right. So then plus, as for this one, our usual. So bring the constant first. Okay, the variable x, okay, squared, then y what cubed. Sapa. Hello, Alpha.
Yes, please.
Okay, so 2 more. Okay, in fact, if you're able to do these 2, okay, a little, okay, addition. You can see that all the examples that we've done under the word example 2, okay, the coefficient of the variable x and y, okay, that we are multiplying, the numerical coefficient, what do we have for each of them?
1.
1. Okay, but the e and f, okay, the e was the numerical coefficient of
2.
that 2, the f,
Negative 3.
-3. Okay, so if the coefficient is not 1, okay, we have a way of dealing with it. Okay, Prof. Ernest.
So please about question D's answer. Why isn't that we don't do it yx by xy?
You don't do what y x by xy.
Like instead, we don't do 3y square x cube,
Oh no,
but
I said it. Oh, sorry to cut you. I said it that it is convenient for us to move alphabetically.
okay. But let's say in an instance, I was rushing in exams, like I was on my last second, then immediately like just muscle memory, I write y like
It
yd
is the
for the
same.
sake.
You can't mark you down. Okay, that's why I said conveniently. Okay, it's the same because multiplication is what is commutative. So if you have three, if it's supposed to be 3ab and you wrote 3ba, it's the same. We can't mark you down. Okay, any teacher who marks you down, okay, maybe the teacher wants you to, okay, what do you call it? Go by the basic rule, move alphabetically. Otherwise, in WASI, we cannot mark you down. Okay, if you mark you down, you can call your lawyer on that particular teacher. All right, you get the point. But move alphabetically. It's always convenient.
Thank you, sir.
All right, okay. So I'm moving on to E. Okay, anything missing in my D?
Yes, please. The
What's
therefore.
the conclusion? Very good. Gideon, I guess that was what you were going to prompt me.
Yes, sir. That's what I was about to say.
Okay, all right. Okay, so I decided to test you this time around. Okay, so it was intentional. You know that I've told you if I'm moving from it's part of me. Okay, if I'm moving from one sub question to the next one, I'll ask myself, okay, whether I've done my conclusion. If I've not, I'll go back. Okay. Otherwise, per experience, I will know that I have to start with therefore. And that's what I'm going to do here. So that I wouldn't have to ask myself. Okay. And it's not in all situations that you start with therefore, you know exemptions. So please take note. Okay, therefore, what am I asked to find? I'm asked to find, okay, it's E. So that is going to give me d dx of what? Okay, 2x what? Y. Okay, so please take note. Okay, you have how many factors?
2.
2,
No, I disagree.
3.
You have three factors, but two variable factors. One, okay, constant factor. Do you agree now?
Yes, please.
Okay. However, if I have 1,000 factors, okay, I can consider it as two factors, just like I told you when we're dealing with binomial theorem. Okay, if you have three or more terms, you can always consider that as two terms. The first two terms will be considered as a term, and the last term also as another term. So if I have 1,000 terms, I can consider them as what do you call it, two terms. Do you get my point? By grouping
Yes,
them.
please.
Okay. Then the same way, if I have 1,000 factors, I can always consider them as what, two factors. I can always. So in this situation, this is what you are going to do. I'm going to give you two ways that you can approach, okay, this. Okay, but the first one will be ideal. And the first one will be, if I'm dealing with this, I can look at this to be, okay, remember this, your factor. Okay, 2xy. So I can consider it to be the product of 2x and y. Do you agree?
Yes, please.
Someone can also consider it to be the product of x and 2y. Is that not it?
Yes, please.
Okay, however, I will advise you always, okay, let the constant, okay, factor be attached to the first variable factor, not the second one. You know that I mean to avoid confusion. So I will go for 2x as my first factor and y as my second factor. So meaning 2x will be my first function and y will be my second function. All correct?
Yes, please.
My professors, do
Yes,
you get the
please.
points I just made?
Yes, please.
Okay, Prof. Frank.
Sir, please, can you do it instead like ddx of 2 times xy? So that I just find ddx of 2 then find xy.
Yeah, you can also, that's why I said you can treat it, okay, in terms of We have, I think, three basic ways. Okay, I mean, permutation. Have you done permutation? No. Okay, I don't think we've done permutation and combination. So this is it. Okay, please take note. Okay, we can, from algebra, we can look at this as two. Once you recognize that there are three factors, we can group them three ways. Okay, I can hold the two. So it will be a product of 2 then xy. It can be a product of 2x and y. It can be a product of what? 2y and x. Okay, and what have you. But the point is, I said, okay, though you can vary, I said, let the constant be attached to the first variable. So irrespective of the variation, this is how we are going to approach it. The constant will be attached to the first variable. So it means I will group the constant and the first variable so that I will get my first factor. And the other, okay, variable become what? My second factor. All correct. All correct.
Yes, sir.
Okay, so that we wouldn't have any variations in our grouping. We are all going to stick to that. Okay, wherever there is rule, there is an order. All right. Okay, so now what do we do? This will be equal to, so this is what I'm going to do. Hold your first factor, which is 2x. Do you agree?
Yes, please.
Then differentiate your second factor. So you find d dx of your second factor. What's our second factor?
Y.
Y. Very good. Then plus, we come and do the swap. Hold your second factor, then differentiate what?
Your first factor.
Your first factor. What's our first factor?
2x.
2x. All correct, my professors.
Yes.
Okay, very good. Okay, so on that note, we are going to get this is equal to. All right, so first factor held 2x. Okay, d dx of y. dy dx. Okay, then plus, okay, second factor held, y. Okay, d dx of 2x.
2.
2, very good. Okay, some of you, your differentiation, okay, on point. Okay, so now this will be equal to, you can see bracket here. So you have to go and remove that final bracket. So 2x dy dx there. Okay, then plus what? 2y. Okay, that becomes our answer. Point well made, my professors.
Yes, please.
Okay, there is an alternative way of dealing with this, and I'm going to walk you through that alternative way. Okay, so this is it. Okay, alt. Okay, what are we giving? D dx. Maximum attention here. The one that sits well with you, you adapt d dx of what? 2xy. All correct.
Yes, please.
Okay, anytime you are differentiating, okay, and you have a constant, your differentiation, okay, usually affects variables. Is that not it? You differentiate
Yes.
with respect to variables. Okay, then so what you do is you can bring the constant out. So this is what I'm going to do. Okay, because of space, I am going to, okay, let me, so that I will see if I can squeeze the E here. Okay, so now this will be equal to, I will hold the 2. Bring the 2, okay, and not hold the 2. Bring the 2 outside. Then this will be the same as 2 times d dx of what? My variables, xy. All correct.
Yes, sir.
Yes, please.
You get it, right?
Yes, sir.
Yes.
Okay, so now my differential operator is affecting xy. Xy is the product of x and y. All correct.
Yes, sir.
Okay, so it means 2 is multiplying the differential of what? Xy. And the product of x and y, I have 2 factors. If I differentiate, how many times am I going to get per the product rule?
Mr. Akman, please, if you differentiate which one? Is it
No,
the
you are
X or Y?
the operator is affecting xy. So if I differentiate xy, you don't know the result, but you know the number of times that it will involve. If I'm using the product rule and I have 2 factors. If I differentiate, how many times do I get?
2.
2 times. Do you agree,
2
my
times.
professors? 2 times.
Yes, please.
Okay, so now this is what we are going to do. You know the rule. Because I'm dealing with two terms, the 2 will come, because the 2 must multiply all the terms. So I introduce a bracket, a square bracket. Please listen. It can be ordinary bracket, okay, maybe the bigger one. But the right thing, because I know I'll have a bracket inside a bracket, that's per experience. So now what is the rule? You hold the first variable or function, which is x. Okay, find dx of y. That will give us dy dx. Do you agree? I'm handling
Yes,
it
please.
maturely. Okay, then plus, come and hold
Y.
my y. Then differentiate x with respect to s. That will give me 1. All correct?
1. Yes, please.
Okay, so this will be equal to 2. I will come and remove the inner bracket here. I can remove the outer bracket and the inner bracket at the same time. But systematically, I'm going to remove the inner bracket here. So I'm removing this bracket. So it's because of this bracket that I have the square bracket. So once the inner bracket here, the ordinary bracket goes, the outer bracket will take the shape and form of what? The inner bracket. So I'm going to get 2. Okay, then my outer bracket here now becomes the ordinary bracket. So I'll get x dy dx here. Okay, then plus y. Do you agree?
Yes, please.
Yes,
Okay,
please.
so now we come and remove the final. Okay, so this will give us 2x dy dx. Am I right?
Yes, please. Plus 2.
Okay, then plus what? 2y. Is it the same as what we had initially?
First one.
It's the same. So between the two, which one will you go for?
The first one.
The first one. Remember, I advised you that, okay, the first one would be ideal for us to go for it. Okay, so in that case, okay, you have varied ways of dealing with it, but we are going to adapt the first one going forward. All correct.
Yes, please.
Okay, or maybe I'll be combining the two so that you sharpen your skills, okay, with respect to the two. Okay, let me see. Okay, so at this point, okay, it means here, if you are going by the old, what we settled on, that's the first one. We are going to treat this one as what? Minus 3x as one factor, then s squared as the other factor. All correct.
No, y
Oh, sorry, y
squared.
squared.
No,
Forgive me. I meant y squared. Okay, take it easy on me, okay? Okay, so that will give you y squared. So it will be minus 3x as one factor. Remember, I said let the constant affect take the constant and the first variable as your first factor. Then your second factor will be what you have there. Maybe, possibly, we will do that. Okay, so let me look at the time. Oops. Okay, Prof. Now, Amale.
Yeah, please. The alternative method, you forgot to conclude.
Okay. Okay, all right. Okay, so thanks for the prompt. So you write therefore here. All right. Okay, so thank you. Anyway, so are we fine?
yes, please.
Okay, so if that's the case, okay, we are going for our water break. When we come back, then we come and look at implicit function itself and how to differentiate. Okay, so welcome back from your water break. Now let's go and look at, okay, differentiation of implicit functions. Okay, how, okay, so you can see that, remember, I just told you that, okay, I have indirectly broken, okay, the implicit function, okay, down into some terms because you'll be dealing with what terms that you have to differentiate. Some of the terms will contain both variables, x and y. Okay, some will contain only x and what? Only y. So we know how to deal with that. So now the basic steps that we have to go through in differentiating implicit what functions. So that will come in terms of what? A relation form. Okay, or function form. So let's see the step. The first one, differentiate both sides of the equation with respect to x. So it means you need to know your differential operator. Okay, so you apply your differential operator, okay, to each what side. Okay, then 2, apply the rules of differentiation. Okay, if an expression involves, okay, y, then include dy dx, just like we said. Okay, if you are differentiating with respect to x and you see y that you are differentiating, you have to attach what dy dx in that particular term. Do you get my point?
Yes, please.
Okay. Now 3, isolate all the dy dx, okay, terms on one side of the equation. So here you can see that so far what we were dealing with, we're not dealing with equations, so we didn't have size, okay, for us to move, okay, to the left-hand side, right-hand side. But with this time, okay, with what we are going to see, we will be having size, so we'll move, okay, the dy dx terms on one side. Then after that, okay, we factor out dy dx. So after differentiating, what you need to do, I mean, after step 2, the step 3 that's up to 5 that we have here basically will mean make dy dx the subject. So if you are making dy dx the subject, you isolate the dy dx terms, then you factor out the dy dx, okay, what do you call it? Factor that you have the expression. Then after that, you solve for dy dx by dividing. That's all that we need to do. So we are going to subject the following questions through, okay, the steps that I just walked you through. So now let's see, find dy dx for each of the following. So obviously, you can see that we are dealing with what? Implicit function relation. You can see equal to in all that we have there. Okay, so let's see how best to deal with it. It's not difficult. Once you understood what we have done previously, okay, before we came here, what we just did before coming to this, okay, our work is going to be easy. So now let's look at solution. Major question number 1. When we are asked to find dy dx, what do you think our differential operator will be?
Y.
Differential operator.
D dx.
ddx, that's it. So the function, so ddx is your operator. The function, okay, indirectly will be y that you are. So you always have to know your operator before you apply your operator. So in this case, A, what are we giving?
Y squared.
Y squared is equal to
Equal to
8x. Okay, all right. Remember, we said, let's go back to the first step. We said we have to differentiate both sides of the equation with respect to x. So if we are differentiating with respect to x, even in what we have here, we know that we need to apply our operator. The operator will be what? ddx, is that not? So you take ddx on both sides. Afa.
Yes, please.
Okay, so in this case, I cannot write therefore, please. This is an equation. So I start with equal to, am I right?
Yes, please.
Really?
No.
You
No,
start with
please.
what?
Therefore.
No.
Implication.
Implication.
The
So you
implication.
cannot, in the implication sign, here you cannot draw your conclusion straight away. So you cannot write therefore because you have this. So I'm now going to write, I'm taking ddx on both sides. Do you agree?
Yes.
So ddx of this side will give us ddx of y squared. And that will be equal to ddx of this side will give us what? Okay, ddx of what? 8x. Okay, somebody's hand was up.
Yes, please. Mr. Akman, please. Like the one we are doing, like, is it different from the rest, car?
What do you mean by isn't different from the rest?
Like
I don't get.
the sign we've placed before the D, why
Mhm.
the D,
The
the X
implication
of
sign.
right? Yes.
Do you mean the implication sign?
Yes, please.
Okay, so even with that one, okay, the one that we did where you are giving f of x, okay, where you are giving f of x, okay, is equal to whatever, maybe 3x plus 2. Okay, you are differentiating. You could have said, okay, this implies that, okay, f prime of x, okay, is equal to, then you different ddx of what you have here, okay, then, but you are using implication because what you were given has equal to in it. You cannot write, okay, this is equal to. You get the point. But we said per
Yes, please.
experience, we realize if you come and write implies that, and you end up coming to write therefore f prime of x. So per experience, instead of using the implication, we wrote what therefore here, so that we don't go and repeat, okay, writing f of therefore f prime of x is equal to our result. Our conclusion will be embedded because whatever that we write here will be what we maintain throughout. Do you get a point?
Yes, please.
So in this case, here, what you have here, unfortunately, you cannot write therefore here. Okay, because your conclusion will be different. You will not conclude with what you have up here for you to write. Therefore, okay, this is as if you were asked to write, find, okay, ddx of y squared. No, you were asked to differentiate the whole of this. So you will know the distinction very soon in terms of how we will conclude what we are going to do. Is that clear?
Yes, please.
Okay, so you use the implication or you can ignore the implication, but you cannot use equal to here because what you were given has equal to. So you cannot start your steps with the equal to sign. That's my point. Is that clear now?
Okay, so yes, yes,
Okay,
please.
all right. Okay, so I saw another hand up, or you are fine.
Yes, please.
Okay, all right. So then let's move on. On that note now, we know how to differentiate. So I'm not going to write the implication. I don't we need to write implication, but make sure, okay, nothing interferes with your implication so that it will simply be understood to be there. So if you find ds of y squared, what would that give us?
2y
2y
dy dx.
dy dx. So you can see where we are coming from. Okay, you have all the tools. So go into your toolbox, okay, and pick. Then if you differentiate this, what do we get?
8 1
Eight
8
one
8.
eight
No,
eight.
8
So
8.
eight. Okay, all right. So we have differentiated. And remember, okay, we said the next step, let me go back. The next step after you apply the rules, okay, apply the rules in the expression involving, so we have attached dy dx to the term, okay, or the expression involving what y. Then we are supposed to isolate the dy dx terms. But how many dy dx terms do you see here?
1.
One. So which is already isolated. Can you see that?
Yes, please. Yes,
So,
please.
so like I said, after differentiating, okay, you make dy dx the subject. So now what do we do? Okay, I want dy dx to stand alone because the question asked me to find dy dx. So I write it again before dividing. So I'm going to get 2y. Oops, my 2 is very ugly. All right. My professors, is everyone following?
Yeah.
Yes, please.
Okay, so 2y will be, so I have 2y dy dx. Okay. Okay, it's equal to 8. I'll write it again, then divide by 2y.
Mr.
Divide
Akon.
by 2y. Yeah. Oh, dy dx. Forgive me.
Yes, please.
Okay, the way you mentioned my name, I knew something was wrong. All right. Okay, so 2y. Do you agree? You are making dy dx the subject. Are we in agreement?
Yes, please.
Okay, Prof. Frank. Prof. Frank, unmute and respond.
Sir, please, can you skip this step and go straight to write dy dx is equal to 8 over 2y?
Oh, remember, as for this one, the Prof. Frank, you've been with me for a while. I've told you if what you have there contains, write it again, a term here, write it again and show your division. I've been saying this times, okay, I'm in time without a number. All correct, my professors.
Yes, please.
Yes,
Okay,
please.
Prof. Benji.
So the two y no is only for the 2y, not for the whole expression.
It's only for the two. I don't get you.
Like you see the first one with the 2y dy dx. When you are dividing, it's only for the 2y, but
Oh,
the
is
dy
it?
dx is not part.
Okay, it's the same thing. Okay, if I give you AB and I ask you to divide by what? A. Okay, you can divide by A here or do AB divided by A. It's the same thing.
Okay,
You get the
sir.
point.
Thank you.
So
Yes, please.
you end up getting the same thing. Okay, the reason why I divided this, I wrote over 2y is that if I write the whole of this one over 2y, I will move into another line. So I've saved one line, though I have established the same point. Do you get the point? Am I clear? My professors, am I clear?
Yes, please.
Yes, sir.
So ordinarily, if I have lines, you will have lines. Okay, so if I'm writing, maybe I'll write 2y, okay, dy dx. Okay, and if I'm dividing, it will be the whole of this one over 2y. Okay, so I will have 1, 2, 3 lines. But I didn't write it this way. I know that it will be the same as over 2y. So that this will cancel, which will be the same as if it's here. This will also cancel the one that we have there, the 2y. So I've established the same point, and I know 2 will go here. So I'm going to get 4, okay, over what, y. Do you agree? Hello, do you agree? Hey, my professors, can you hear me?
Yes,
Yes, please. You
yes,
can
sir.
hear.
Okay, so Prof. Caro, your hand is up.
Mr. Akman, please. The step where you wrote the to where we were dividing. Step, please. Is it that you are dividing both sides by the coefficients of the x?
Yeah, you are making dy dx the subject. So in math, anytime you are making a quantity or a variable the subject, you divide by its coefficient. If the coefficient
Okay.
is not 1. You get the
Thank you. I
point?
wanted to verify. Yes,
Okay,
please.
all right. Okay, so now you know the question asks you to find dy dx. Is that not it?
Yes, please.
So you have the dy dx. I can put my therefore here. So that's the more reason why here I didn't put there. If you put therefore here, as if you were asked to find d dx of y squared. The question this time around didn't ask you to do that. So putting the therefore here will be a problem. You only put therefore where after you found what? Your dy dx. So you can see the distinction. And you can also see that from this, whatever we've done here, as we move from one step to the other, okay, the quantity here, the result that we have here, the expression here changes. Unlike the other one that if we're given f of x is equal to maybe 2x squared minus 3x, and you come and find d dx of this, which is f prime of x, okay, is equal to 2 d dx of what? Of the quantity that you have here. I just want to save time. So the next step, what do you write? Ordinarily, you would have written f prime of s is equal to f prime of s is equal. So you can see that, okay, the next step, the left-hand side, you'll be writing the same thing. But here, the left-hand side, from step to step, we are not writing the same thing. Okay, because here we were writing the same thing, so you could have put, or we could put the therefore there. But here, we are not writing the same thing, so you cannot put the therefore. Do you see the difference?
Yes, please.
So
Yes,
take
please.
note of that. Okay, these are some of the things that you need to know to exhibit maturity in your presentation. Okay. Afa, my professors.
Yes, please.
Great.
Yes, sir.
Okay, so now I'm going to clear this, having made my point. Okay, so now let's see. Okay, what we are going to do. Give me. Okay, so the next one, we are done with the first one. Give me just a minute. I'll be with you. Okay, so now let's go and look at the B. Okay, B, what are we giving? X squared plus y squared. Okay, is equal to what? It's equal to 4. All correct.
Yes,
So
please.
it's different from the first one. The first one, you have a term each on each side. Is that not it?
Yes,
So this
please.
time around, one side you have 2 terms and the other side you have 1 term. But no issues, it's the same, okay, steps that we are going to subject this one also through. So the first step is to differentiate, okay, both sides with respect to x. So you know your operator. So it means I'm going to write, this implies that d dx of my left-hand side, the left-hand side has more than a term. So I'm going to put it in brackets. Is that clear?
Yes, please.
Okay, so that my differential operator will affect both terms. And it's equal to here, I have only 1 term. So d dx of what? Of what? 4. Okay, I can choose not to put it in bracket. Yes, I can. Afa,
Yes, please.
Okay, so now listen. Okay, we are finding ddx of x squared plus y squared. So your differential operator is first of all affecting two terms. Is that not it?
Yes, please.
So we have to differentiate term by term. Do you agree?
Yes, please.
Yes.
Okay, so can I say that what I have here is the same as ddx of my first term, which is x squared, plus what ddx of my second term, which is y squared?
Yes, please.
My professor, do you agree?
Yes,
Sir.
please.
Okay, and this will be equal to ddx of 4 is what? The differential of a constant.
0.
0. All correct.
Yes, sir.
Yes,
So we are in
please.
a comfortable lead. Okay, ddx of x squared will give us
2x.
2x. Very good. The variable here is the same as that, so no quantity dy dx to be attached. Remember, I said we test the term containing y is the one that will have dy dx. Okay, so now what do we do? Ddx of y squared will give us our usual y squared.
2y.
2y
Y dy
dy
dx.
dx. Very good. Okay, you are doing well. Keep it up.
It's equal
All
to
right.
0.
Is equal to
Is
0.
equal to
So now the next step is to make dy dx the subject. So isolate, okay, in making the dy dx the subject, first of all, you have to isolate our dy dx term or term. So here you have only one term. So we are isolating. So it means you have to move this one to that side so that this will stand alone as a term. So you are going to get 2y dy dx. Alpha is equal to
yes,
negative 2x. Do you agree?
yes,
Please.
please.
Okay. The
Over.
next step, should I come again on my point is well made by professors?
Which is wrong.
Okay, so
It's
now
wrong.
the next step, okay, is to divide both sides by which quantity?
Dy.
No,
2y.
2y, because you are making
2.
dy dx the subject. So you differentiate by, you divide by your coefficient of dy dx, just a term. So now what do? We are going to get, okay, so let me write, you know what you are supposed to do before you come to this. So I can say that my dy dx will be equal to, I've divided mentally, minus 2x over 2y. All correct?
Yes, please.
Okay, so now, okay, I can reduce this. So where I'm reducing, that will land me at my answer. So I'll write, therefore, my dy dx that I was asked to find will be equal to, this can be reduced. So that will give me minus x over y. All correct?
Yes, please.
How far, my professors?
Yes, please.
Okay, someone can also put therefore here, but the person will know that this can be reduced, then you come and write equal to, then give the reduced version. In any case, you still draw your conclusion. Afa.
Yes, please.
All right. So, okay, Prof. Gideon.
So please, but you can skip the step after the implication, right?
You can skip the step afterwards. Yes, as you mature, you can skip and differentiate mentally. Is that okay?
Okay, sir. Yes,
All right.
thank
Just
you.
as said, just like I said in the, what do you call it? Our previous differentiation techniques rules. Okay, so now let's go and look at the next set of questions. So C and D, let me look at the time. Oops, at least we should be able to do maybe two more. Okay, we couldn't finish. Okay, get my target, but that's okay. All right, so C, once you understand, that is key. C, what do we have? We've been given S cube plus what? Y cube. Okay, is equal to what? 9. Okay, so we differentiate both sides with respect to x. So we are taking d dx, okay, of this side more than a term. So you put it in brackets. It's equal to d dx of this side as well. Okay, so we are going to differentiate, but this time I will do it mentally because I can differentiate term by term mentally. It's easy. Each of the terms contain only one variable. So I can say that I can write implication here or ignore, but let's learn to, okay, use the implication so that we'll know when to use the implication and when not to. So now it will be d dx of s cubed, which will give us what? 3s squared. Do you
3x
agree?
squared. Yes,
Yes.
please.
Then plus d dx of this, which will give us 3
3y
y
squared
squared
dy
dy dx. My professors, I hope you are following.
Yes,
Yes.
please.
Okay, that should be equal to d dx of 9,
0.
0. So now the rest will just be change of subject. So what do? We maintain this is positive, so we maintain it here, move this one to the other side. So you give us 3y squared, okay, dy dx, isolated, okay, is equal to minus 3s squared. Do you agree?
Yes, please.
Okay, you write it again, then you divide by, okay, what do you call it? 3y squared. Do you agree?
Yes,
Okay, so
please.
you end up getting dy dx
It's equal to
is equal to minus
negative
3s squared, okay, over what? Okay, 3y squared. All correct.
yes, please.
Okay, so this can be reduced. So I'll come and write, therefore, my dy dx, the reduced version will give me my final answer. Okay, it's equal to, and this will cancel, so I'll end up getting minus s squared over what? Y squared. Afa.
Yes, please.
Okay, so now one more. Okay, so I think, let me see. Yes, I'm going to do one more. Between D and E, which one do you want us to do? Okay, hurry up. One more.
Is E.
E.
We should do the E. E.
Yes, please.
I saw it coming. All right. Okay, so E. Maximum attention. If you're able to do E, you should be able to. As for F, it's in green. We can no go area. We can't touch it. Okay, so what do we have? E, we are giving S squared plus what? Y squared. Okay, minus 2x. Okay, minus 3y is equal to what? 3. So first step, we differentiate, okay, both sides with respect to x. So we take d dx of both sides. Okay, now we are going to get d dx, okay, of the whole of this, which is what? X squared, okay, plus y squared minus 2x minus 3y, okay, is equal to what?
3.
ddx of
d
3.
dx of what? Of 3. Be careful, not 3. It's an equation, so whatever you do on one side, you do same on the other side to keep the equal to sign valid. So now, you know how many times here?
3.
Okay, 3. Are you sure?
4.
4. Okay. All right, Prof. Now, Mali.
Sir, please, this time you didn't put the implication sign.
Okay, all right. Okay, thank you. But remember, I've told you, the implication sign, if you introduce, just like I advise you to use equal to sign when you are dealing with expression to introduce your steps, basically is to help us easily distinguish our steps from each other. Okay, however, when it comes to implication sign, you can ignore because whenever you are using implication, there will be inequality or equal to sign involved. So we can still use the equal to distinguish the steps from each other. I'm talking about, so I can say that, okay, this step that I have the equal to here will be maybe one step. Okay, the next one you have equal to. Okay, so without the implication, you can ignore. That's my point. But the equal to, you cannot ignore. Are you with me?
Yes, sir.
Yes.
Okay, however, remember the advice. I said, okay, I want you to know when to use the implication. But if you ignore, it will not be costly. Okay, I've told you. So now we know we have terms, so we differentiate term by term. Is that not it?
Yes,
We are
please.
going to do that mentally. So it will be d ds of s squared, which will give us 2x. Do you
2x.
agree? D ds
Yes,
of y squared, which will give us our
2y
usual y squared. 2y
dy dx.
dy dx. Okay. So minus, if you differentiate this, we are going to get
2.
2. Now, professors, I hope you are with me.
Yes, please.
Okay, then minus, okay, 3. If you differentiate y with respect to x, we are going to get, there will be a dy dx term. So it will give you 3 dy dx. Am I right?
Yes, please.
Is everyone following, my professors?
Yes, sir.
Yes,
Okay, that
please.
will be equal to what? 0. Okay, so how many dy dx terms here?
2.
2, because you have 2 terms in y. You get it?
Yes, please.
So here we are going to isolate, okay, 2 terms in dy dx, unlike the previous one where we had only 1 term. So these 2 terms must be isolated. So I'm going to have 2y dy dx, okay, minus, okay, 3 dy dx. So you can see that anytime I'm writing, I write close to the margin, moving from one step to the next step, I write close to the margin, dy dx, and that will be equal to, I have to move this one to the side, so that will give me minus, okay, 2x. Is that clear?
Yes, please.
Okay. All right. So now the next step is to factor out your dy dx, because here we have more than a term. The other one, the step that we said you have to factor out your dy dx, okay, was not necessary because you had only 1 term in dy dx. Okay, Prof. Benjamin.
Say,
Mhm.
say, in the first expression we have -2 there, but when
Very
in the
good.
second
So
expression,
please take note, and perfect. Okay, I was going to draw your attention to that. How many terms do you have here? 1, 2, 3, 4. Okay, so it means if you isolate, you are going to get 2 terms on this side and 2 terms on the other side, because 2 of the terms were the one in dy dx. So when you are moving, you have to be very careful. So it will give us minus 2x then plus 2. Is that not it?
Yes, please.
However, remember the advice. It's better you write the positive term first. So I'm going to write the 2 here. All correct. If you had taught before writing. My professors, are you with me?
Yes,
Yes,
sir.
please.
Okay, we've gone a little beyond our time, but please pardon me. Okay, so this is what we have. So at this point, we are going to factor out dy dx. So can I say that what I have here is the same as, okay, 2y minus 3, the whole of that in bracket dy dx is
yes,
equal
sir.
Yes,
to
please.
2 minus. Do you agree?
Yes, please.
Someone can bring the dy dx first, followed by this. Multiplication is commutative. Any which way will do. Is everyone following, my professors?
Yes, please.
Okay, very good. So the next step is to divide both sides by, this time around, the coefficient, okay, 2 terms. So I'm going to have, therefore, my dy dx, okay, because at that point, my dy dx will stand alone, will be equal to my numerator here, which is 2 minus 3x, sorry, 2x, forgive me, all over what? 2y minus 3. Do you agree?
Yes, please.
We cannot reduce this. So this is how far we can go. So we are done. Points well made, my professors.
Yes, please.
Yes,
Okay, so on this note, we are going to bring the curtains down. Okay, there is another set of questions where the example 2, where you can see that all the example that we worked with here is either the term is in strictly x or strictly y. So the next set of example, you will see a particular term in both x and what and y, where we have to apply the product rule. Okay, so unfortunately, we couldn't end, okay, where I wanted us to, but fortunately, whatever that we've done, okay, we are able to understand and understand perfectly. Okay, so that will be it for this particular meeting. Maybe I will check if I have an assignment. The assignment covers whatever, let me see, whatever I have. Okay, it involves the product. So it means if I want to give you any assignment, I cannot give you the product one because I haven't walked you through how to do that. So we are going to end here. Wait, if there is any assignment, I'll put it on the class page. If not, okay, then you use it to revise. Okay, thank you very much. Okay, please, bye-bye.
Bye.
God bless us all.
Bye.